Hey everyone, welcome back to my YouTube channel, Steve Learning Notes. Continuing my journey in learning Elixirs, I decided to try a small challenge, creating an application to analyze weather data, and it will produce a simple statistic. And while doing that, I found a new concepts in Elixir. So in this video, I want to share those new concepts with you, such as Struct, Sigils, project structures, and so on. Yeah, so I hope you can enjoy the video. Okay, I will show you the simple demo for the library. So I will bring up the IX sessions. Now I'm inside the interactive shells. Now let's just create a new variable code file, and this will be a path to the CSV file that I have prepared before. Paste data /txt, right? And then what I'm gonna do, I will load the weathers with the functions from lpo stats load weathers, and then just pass the file, right? And this function return tuple of OK and the weathers, right? So now I can access the weathers list. Great. Now I can call functions like get, and then here I have things like get wind, let's say directions, and then just pass the weather's variable that we have set, and it will return a map that has mean and median keys. And then let's try again with different function. This time maybe barometric press. Pass the weathers, it will calculate the mean and median values. So that's the solutions from me. Okay, I will show you a little demo about Mix Tools. It's a tool that we can use to generate an initial code for Elixir project. So the command will be mix new and your project name. Let's say lpo_stats, right? It will create lpo directory. So let's go inside. Great. And it will provide you with a bunch of files and directory for you to begin the project. Right, it will provide you the default README files with some installations instructions. For example, this is inform you that you can publish your documentations, and then inform you how to install your library. And then it also gives you git ignore files, so you can see all the things that we can omit when pushing our codes to the repositories. The important thing here is probably the mix.exs file, which is a module that contains projects level configurations like your application name, versions, Elixir versions, and also where you can see your dependencies of this library. So for example, if you want to install a new dependencies, you can put your new dependencies here. and then install the dependencies with another mix command. And then it will also gives you one modules already, which is in the lib, like that. And then it will gives you also the test file or the test directory, right? So here we have test helper.exs, which is triggering the exunit.start function, which is required for us to use exunit. And then also it provides the default test file already, test case already, like this. So you can get the idea and then expand the code based on your requirements. And also you can run the test by using mix test, right? It will run the test, and then also mix format for you to format the codes if it's required. In these sections, I want to share with you about Struct in Elixir. So let's begin by creating a module called, let's say, user.name, which will handle the first, middle, and the last name of a users. And I want to create struct to hold those names. To create a new struct, I need to use def struct macro. It accepts fields of the struct as the arguments. And we can define the fields by using atom like this. First, and then let's say middle, and then last. That's it. And then to create the new struct from this module, we can use this syntax percent and then the module name and then curly branches. So if I just do this way, it will create the struct users with default value of nil. So that's the default, and it means first, middle, last are optional fields. So let's say I want to change the default value to empty string, right? Let's say middle, right? Middle, I want to change it to empty string. So because I want to use keyword list, I need to move it to the last positions and then provide the default value, middle. So if I recompile that, now middle will have empty string as the default value. What if I want to make first and last as required fields? To do that, I can use a special module attributes called module enforce keys, and I just need to specify the attribute that are required. In this case, first and then last. So if I recompile again and recreate the struct with empty fields, it will throw an argument error saying that first and last are not there in the struct. Percent user.name, so that would be first, and then last will be go, right? So first, last, and middle. Okay, cool. So what if I don't want to repeat the writing of these two fields? I have written these two fields here, but also written here. So to avoid these duplications, if you want, you can actually combine these two data because they are basically type of list. So you can just use a plus sign like that and get rid of these two required fields that already written in the enforce keys, and that will still work. Right, cool. Now let's create a functions called get full name. So these functions will return the full name of the users, the combinations of the first, middle, and last. So the argument or the parameter here will be name, the struct of the user.name. And let's create these functions quickly. So I will use list name dot first. This is the order. Name dot middle. Name dot last. And then I will use enum dot reject. I don't want a name with empty string. And then after that, I will join the list with empty space as the joiners, so it will return binary, right? So let's try our new functions. So we have these users. Let's put it in the variable. All right, and then let's call our function. Yeah, full name user1 John Doe. All right, so next I want to create the spec for this function spec, and the spec something like this, right? So but we don't have type for our struct, so we need to create type for our struct. We can use type to do that. Add type, and then for the name alias for our struct, by conventions for type it will be T, something like that. That's the conventions in Elixir. It doesn't need to be T. You can use maybe user name, something like that. But the conventions for alias for type in Elixir is T. And then after that, we need to define the fields for our type. The syntax will be percent and then the name of your module. But instead of type the name manually like this, the best practice is to use macro of modules, which will give you the module name automatically. And then here we need to define the type for each of the fields. For example, first should be type string. So you can see here string type also use T for the name of the type. So that's kind of like conventions in Elixir. And then middle, it's also string. Let me just copy for the last. And then here in get full name, we just need to use T like that and return binary in this case, because joined will return binary, right? So that's it. So T here will refer to user name struct, right? So everything should still work as it is. Yep. So that's the basic of Struct. Alright, so in these sections, I want to show you how we can generate documentations using exdoc. Go to the exdoc documentation. There is a section called usage. Here you can just copy this line over here, go back to your co-editor, open mix.ex as file, and then paste it into these private functions tabs. Right, save it, and then in your terminals, you just need to run mix dabs.get, which will basically get all the dependencies that you specify here. After that, it will download all the files necessary to generate the documentations. After that, you just need to use this command mix doc. Ah, sorry, it should be mix docs. Yeah, mix docs. So that will generate this doc folder. If you open up, you will get index.html right here. So surely it's not visible from here, so I will open it from my browser. Whereas WSL, right? All right, I hope it works. Okay, so here in the doc, index.html. So this is the generated documentations, and if you click modules, there is only one module here, user.name, and then if you click that, we have types. This is the type spec for the type, and it's clearly visible for the users that this type has these fields: first, last, and middle. Yeah, we also have these functions, right? Right. So I want to introduce opaque type. So here we use add type. It means this type is publicly available for the users, so the users can basically reference this type into their code. They can deconstruct this type, they can pattern match this type. All right, but what if we want to make this type private only for these modules? We can use type P instead, right? This will make these modules private, right? So we can generate again the docs and see the difference from the documentations. The type here, it's gone, right? It's gone. It's not visible, right? Because it's only, it can be only used within the user.name modules. But what if you want to make this type still can be used by another submodule of users, right? So instead of using type P, we can use opaque here. Opaque, right? So let's generate the docs again. Refresh it. So the types here becomes visible again, but the internal fields of the structs is hidden, right? It's not visible. How we define that types internally is not visible. So these types still can be accessed by, let's say, other users modules, but it should not be used outside the users modules. So the users of this library, let's say we have user library, they should not use or deconstruct this type outside the library. So if they want access to this type, they should use all public APIs that is provided within these users modules. So that's the idea of OpenQ. So that's the difference between add type P, and add OpenQ. Okay, in these sections, I want to talk about project structures. So this is a GitHub from Christopher Adams. He has like a Elixir style guide. There is more than one style guides over there, but I will just use this as a reference. There's a section called modules. And he said that one module per files unless the module is only used internally. Okay. And here's the interesting thing that I think we should follow this path. That basically, if you have module named some modules, the file name should be use a snake case like some underscore modules. The same name with the module name, but using snake case. And then we need to represent each level of nesting within a module name as a directory. So for example, if we have parser.core.xml parsers, so this XML parsers file need to be put inside parser/core/the modules. So in that case, if we apply that best practice to our user.name modules, it means that we need to create a new folder called user and then put our name module inside that. Great. So user.name is under user/name.ex. And then outside in the level of the lib, we need to create our main module of user. Right? That's the idea. But it does nothing right now. We don't have anything here. But that's the idea. Like this is the main modules, and then this is the sub modules of the users. So that we can also improve our documentations. So when the documentation is opened, the index.html, it will show the users documentations because this is like the main modules. So to do that, you can open the exdoc documentations. So here there is a sections of configurations of the documentations. Right here we can specify the main page for the documentations. Right, so let's try that. Let's go to mix.dxs and define our docs private functions, and the main page for our doc will be users, right? So we don't have the path. Maybe we can get rid of it. And then what else? So we need to specify that in our project functions right there. Maybe that's enough. So let's regenerate our documentations. Great. And then all right, so let's refresh that. So here our index.html, the entry level, right? If we click, the entry level of our documentation is the users module. We don't have anything for now. And then the submodule will be under that. So it create a nice structures and nice idea for the developers that this is the main modules, the main APIs, right? And then this is the submodules that we have. So next, I will show you about error handling in Elixirs. There are two ways of saying that something went wrong. First is by using exceptions, and second by using error tuple. So now let's see how exceptions works first. So let's say I want to create a validations that name, first and last name should not be empty string, right? Because right now, first and last name can still be empty string, but I don't want that. Sure. So let's create a constructor functions called new, and it will accept a map and do like that, right? And I will call struct with acclamations functions, and it needs the modules or struct and any enumerable. So for the modules, it will be module and the enumerable. Right, let's save that. All right, so let's create the struct first. I will create a user map want. This is for our test case. All right,
I want to define that first. So first is empty, and second, what is it? Class, right? Class is empty, and second one is first is don't, and then the third one is this is empty. Class is do, right? And then the fourth one is everything is available, including maybe the middle, like ballots, ballots. Right.
so let's try our new function first. So user dot name dot new, and let's try our first map, user map one, and that still works because we don't have the validations, right? And I'm using acclamation here so that the def struct, so that the enforce keys validation works. So let's try to create a new functions above this by using a pattern matching. So new, I will use acclamation here too, right? The pattern matching will be any map that has first key, but the value is empty, right? I will rise argument exceptions with this message. First name is empty, right? Something like that. And then the second functions, but this time for last, I'll say last name is empty. Right, that's our functions for validating. So let's compile this. Now if we try again with map want, it will throw wait. Oh yeah, new acclamations. It will throw argument error, say that first name is empty, right? That's expected now because user map 1, the first name is empty. Let's try with user map 2. User map 2. It also throw argument error, say that last name is empty. And let's try with user map 4, and everything is fine. Cool. Now, as a client, if you want to use function that can throw an exceptions, you can let your application crash, right? Just not checking the arguments, or you want to check the argument and do something with it. So to do that, you can use try do and then something that you want to trigger, user.name.new. We know that this function will trigger an exceptions, so we want to catch that with try do and then rescue. And then for example, I want to catch argument error, and if that happened for this demo, I will just say, hey, something went wrong, right? So for just sake for demo, and right, hey, something went wrong. But if you use the correct map, it will return the user's struct as it is. So that is the first error handling in Elixir by using exceptions, and then we can catch that exceptions by using try and rescue keywords. Okay, so this time I'm going to show you the second error handling in Elixir by using error atom. So to do that, usually we create second version of new, but without exclamation mark. It means that it will not throw any exceptions. So we need to change this. Instead of raising argument error, we use tuple of error as the first value. And the second one, it can be the message of the error. But in this case, I like to return argument error with the exceptions message first name is empty. So these functions will return error, and the second value of the tuple will be the argument error exceptions. So I can do the same, but now use last name is empty. All right. Maybe I should need to remove that. So let's try it. So now I will trigger these functions, and it will return tuple with the first value is error atom, and the second one is argument error with this message. And that's also the same with empty last name. But if we pass a correct map, use a correct map, usually the pattern is that returning OK, indicating the functions has no problem, and then the struct. So right, so it will return OK and the struct. So now if I client want to use this functions that returning tuple, how do I do the check, right? Well, we can do that by using pattern matching. So there is a couple ways of doing that. So first is by using conditions. Condition or case, I mean case these functions do, right? If these functions returned, let's say error tuple, and then here will be the error message, right? Or in this case the exception, let's call it just E. Then maybe I will just return E and then get the message maybe. And then, but if I get OK, and then I know this will be the user, I will just maybe print the users and add, right? So this will return us the message of the exceptions, which is first name is empty. But if we do that again with the correct map, like that, it will return us the struct. So this is, we can use case conditions to check if this functions returns error items or okay item. And then in the context of, let's say, library, if we create a library, it is a good practice to provide the non-throwing exceptions functions and let the users of the library decide whether they want to throw an exceptions or handle the errors gracefully at their ends. So that's it about error handling. All right, these sections I will share about Sigil. So to explain about it, I will create a new functions called get, let's say, not get, let's say parse birthday, right? And let's just create a spec of it. So this spec will be parse birthday, set binary, and returned date struct or date types. And then let's also provide the documents. This will parse YYY underscore underscore DD to, let's say, that dot T. Sounds good, right? Yeah. So this is the functions documentation and this is the spec. So how we can implement it? So we can implement it in different ways, but for this one, I found a cool pattern matchings tricks by using binary pattern matching. So I can do this. Like I want to get the year, which is binary, this is a binary size 4. It means that the first 4 binary size is the year, and then after that is underscore, and after that I will get this should be double colons, right? And then this should be in here, and after that I want month string or binary for the next 2 size. After that underscore again, and after that is the last 2 binary is the day. So it's month and it's day. Save that, right? So I can call dot new functions that require integers as the argument. So we need to convert this to integer. It's y. Let's copy for the month and for the day, comma and comma. So that is our functions. And let's create example test for this one. IEX, I believe that's how we do it. User dot parse birthday, and then let's say the day is 2025 underscore 12 underscore 31, and that should give us, let's say, that dot new, right, to Alright, something like that. Oops, what happened with my keyboard? Sorry. Right, something like that, right? Let's try to run the test. And then let's go to test directory. We have demo test, but we don't use it, right? Let's rename this to user. Let's rename this to user. Rename this to user. And remove this. We don't need that. Great, let's run this using a mix test command. Right? Everything's works as expected. Let's check if we set it as 11. That should throw an error, right? Saying that invalidate. So we should change it back to 12. Yep. All right. So this is called binary pattern matching, right? So that's just an intermezzo, but I'm here to explain about Sigil. So Sigil is basically an alternative way to define a types in Elixir in a way that it looks more readable or shorter to define the types. So instead of writing the dates like this, date.new and then the dates, we can just use sigils. So sigils is like this. How do you say it in English? It's like these worm symbols, right? And then use D, right? And then use the text like this, if I'm not mistaken. Let's see the documentations. Right, so Elixir Sigil. Alright, Sigils. Oh, that's in Japanese. I don't know. So Sigils like this. Oh, tilde. Alright, so the worm symbols is called tilde. Okay. So you can, let me say for the dates. Yeah, something like that. Alright, so I need a square here. So this is how Sigils looks like. So between this and this, they are basically the same. So let me just open up IX sessions, and between this and these are the same. It should return true. It should return true, right? So between the two are the same, but the later is more shorter, easier to read. So if I run mix tags again, everything is fine. So that's a sigil. Another example, let's say if I have a, let's say fields of users, and then I would say like full name, comma, and then like this is birthday, comma, age, comma, let's say country, right? Something like this. And then let's say I create a function called fields that will return fields attributes, right? Okay, I will run ix mix sessions and I can call that fields, right? That gives you the list of words And I can do this like this, but I can also use Sigils using tilde W, right? Change the square bracket with this bracket, and then I don't need to use quotes here, and even I don't need to use comma here. I can remove everything, recompile, call it again, and it's still the same, but look, it's more simple. It becomes a wordless, and it looks more simple than the previous one. And then if you want to change these fields into atom, Sigil provides a second like argument, kind of that way. So this is called a modifiers, and this is a modifiers, meaning it can change this word list into atom. So if I compile this and write again, suddenly it becomes atom without needed to type the codes. That's very handy. In these sections, I want to show you that we can also create our own sigils if it's required. So I already prepared the code here. I called the modules util.mysigils. So to create the sigils, you need to define functions with this name like sigil underscore, and then the character for your sigils. In this case, I use and, specifying number, that number of string that we can convert it to, let's say, float or integer numbers, right? So this is the functions header that does nothing. This is just for documentations. And then I have sigil and, but with f modifiers. So this question mark over here means a Unicode code base something. So here, Unicode code points. So this is represents the code point in the Unicode table, like the numerical index, right? Like that. And then the implementation is just basically, in this example, convert the string to float, but trim that first, right? So basically something like that. So also the same with integer, but if there is no modifiers, then I need to check if the strings is float or integers by using regular expressions. So the regular expressions, I use conditions case. So it means that this will return true. This will be returned if this conditions is true. So if these strings match with these regular expressions. So as you notice here is another sigil of regex. So you don't need to call something like regex.compile, something like that. Just need to use sigil like this, and then the regex patterns after that, right? So if the string doesn't have dot, then it means float, otherwise integers. But if there is no like digits, I will return error, something like this. So how to use it, right? We need to recompile this. Oh no, I have recompiled it before. So I need to import it, import the module unit, not unit, util dot mysigils, right? And then use it. For example, and I have this digits that will convert to integers. And if I turn it to float, that becomes float, I can also use the modifiers like that. Oh, I need to use comma here, right? So something like that, right? So that is the custom Sigils if you need it. All right, so in this session, I want to talk about enums and streams concepts, about eager versus lazy concepts in Elixir. So I have two functions, run in eager example and run in lazy example, both doing the same thing. So I have range from 1 to 10, and then for each numbers in this range, I will do filtering, which is I will only include an event number. After that, I will double the number and sum the number. The same also goes to here, lazy example. But the difference is that here I use streams instead of enums. So let's execute the eager one first. So as you can see here, what happened is that in enum, when the data is processed in the first step here, it creates like a collections, and then it will wait until all data in this range have been processed by this log and filter event, as you can see in the log. And after that, it will continue to the next steps. Now, if I execute the lazy example, and as you can see here, instead of waiting, it will process the numbers one by one. So that's why it's called lazy. So this is useful if you have like very large numbers of data source, or maybe even infinite data source, like streaming, like it's infinite. And then you want to ensure that you can somehow control your memory usage. So we can test that performance using Benchy. It's like a tools to do benchmarking tests in Elixir. So as you can see here, I have a script called bench.exs. The S here means script. So I want to use Benchy, and then this is exactly the same functions that we have seen, and I will call benchy.run with this label over here, and then it will call our functions with this data. So this is too small, so I will increase that to, let's say, 1000, right? So let's see. I will exit, and then using Elixir bench exs. Yep, calculating statistics. Thank you. So as you can see here, you can see maybe I will, right? You can see the results of the statistics. IPS means iteration per seconds. So if the number is higher, means that it's faster. And then you can see here the stream one is slower, like 1.43 times slower, but it's still in nanoseconds. So maybe it doesn't really matter. And the memory usage here, somehow the streams consumes bigger memory than enum. But I said before, it's supposed to use less memory, right? So probably because the data here is not that big enough. So in that case, let's maybe increase the number, maybe 100,000. Let's see. Let's run that again, the benchmark. Right, so as you can see here, for the results, it's still slower and it's still using more memory. So if you compare that to previous one, it's pretty much the same, like 1.43, 1. It's a bit faster, right? The stream one compared with the previous benchmark test. Previous one is slower by 1.43. This time is 1.27. The memory usage 2.37, and before it was 2.5. So the memory usage, if we compare with the previous run, is actually less, right? But still bigger with the enum one. So let's increase that to 1 million. So as you can see here, now enum is actually slower than stream. In terms of memory usage is still lower than stream. So let's increase it to 10 millions. Now if we see the enum is slower, yes, and then the memory usage of enum is still lower than the stream. Let's increase to 100 millions now. Alright, still running. So the benchmark is killed. I think it's OM. So let's see. Let's try to execute it one by one. Comment this stream and just execute the enum. So it's killed, right? But if I comment the enum, just execute the stream. So this is the memory usage and this other statistics. So the summary is that it needs like a really large number of processings, right? So that eventually the enum one becomes OM, the process is killed, and at some point the stream one becomes faster than enum. So it means that enum itself, it's okay, like in terms of performance, still fine in most cases. So, but now we know that we have options to use enum or to use stream. I hope you enjoyed the video. As always, keep learning and stay healthy. Bye bye.